LM can be used to perform a t-test. When you give him two groups, he will do a t-test. LM can be used to do a one-way ANOVA, when you have more than two groups. And LM can be used to do a two-way ANOVA. So LM can do a lot of things. Does anybody recognize this function? We have used it before. Linear regression was done using the LM function. Remember linear regression, fitting a line to your data? So this is exactly the same approach that is used in R for comparing groups. R performs a linear regression on the data. So this is the use of linear regression for comparing two groups. I'm sticking here to the simple case. We have two groups that we want to compare. What will LM do? LM will fit this line. How does it work? Well, when you have groups, you put your groups on the x-axis. The y-axis is still continuous. It contains your measurements, but the x-axis now contains groups. The first group is called 0. The second group is called 1. You have your measurements, so you have multiple measurements for group 0, and you have multiple measurements for group 1. So these are the two groups that you want to compare. LM will fit the line. Fitting the line implies that you're going to solve this equation. This is the equation that represents a line, a plus b times x. And what LM will do is it will try to find the optimal parameters a and b, so the best values for these two parameters. So the parameters are found because he searches for the line that gives the smallest residuals. And remember, the residuals are the difference between your data and the line. So he will search for the line that gives the smallest residuals. And in the case of comparing groups, that line will go through the means of the two groups. But only when the data are normally distributed. Otherwise, this is not true what I'm saying. So he fits the line that gives the smallest residuals. And by doing that, he will find the actual values of A and B. And A was the intercept. So A is the distance from here to the line. And since the line will go through the means of the two groups, the intercept, or A, is now nothing else than the mean of your first group. The parameter B represents the slope. What is the slope? Well, the slope is defined as follows. When you go 1, you move 1 along the x-axis. So you go from 0 to 1 along the x-axis. How much does your line go up? Yeah? So the slope is basically, in this case, this distance. Yeah? You go 1 along the x-axis. How much did you go up? And because this is the definition of the slope is nothing else than the difference between these two means. And this is what you call the biological effect. So doing this linear regression has a lot of nice features. You can find the means of the groups and you can find the biological effect.